We're continuing our introduction to the foundations of the course, and next up is Python. And today we're going to talk about why are we using Python in this course and how I use Python personally. Let's first get something out of the way. There are 3 short videos on Python this week, and there's no way that I can teach you how to use Python in just 3 short videos. However, there are tons of help online to learn. What I'm going to do is review the parts of Python that I use the most and that you'll definitely need for this class. If you're already familiar with another programming language, this might be enough for you to get started with how we use Python in this course. Let's first start up Python. I'm going to do everything in Apple OS X since it's a nice balance between Windows and Linux. It kind of has some of the flavor of both, which some of you might be running. I'm also going to be doing everything on the command line. You might use an IDE or a notebook, that's totally fine. But I think for someone seeing this for the first time, I think it's better to see the stripped down version without additional complexity. If you haven't seen a command line before, it's usually this black box called a terminal window. Let's zoom in so this is all we see. Doing it this way is also useful if you ever switch to using AWS or Google Cloud, where your best and sometimes only means of interaction is the terminal window. In a terminal window, you type the name of the program you want to run. In this case, we're going to run the program Python. Once the program starts, the first thing that you see is the version of Python that you're running. Make sure that it's at least 3.5. The minimum version may be higher in the future. We're recording this in fall 2020. Now we're in Python. Python is a beautiful programming language. It's very simple to learn and it has great library support. Oftentimes, what you want to do is very easy to find on the web. Someone has already written the code and you can just type import solution and get what you need to do out of the way really quickly. Normally, we'll be running whole Python programs that are in a separate file. We'll get to that in a later video. But first, let's introduce some of the basic data types of Python operations and show you how Python works and why it's such a beautiful programming language. Let's start with whole numbers. 22 is an integer, and if we divide it by 7, we get 3 and a little left over. Let's see 3 kinds of division we have in Python. Integer division, where the inputs and the outputs are integers. In this case, it gives you the answers disregarding any remainder. If you actually want the remainder, in this case 1, you have to use modulo division, which uses a % sign. So here we get that the remainder, when you divide 22 by 7, is 1. The inputs and the outputs are all integers, which we can see using the type command. This command tells you what the type of an input is. In this case, it's an integer. Still, these answers might be a little different from what you're expecting. The usual division just uses the single /, which gives you a little more than 3. But the answer is a different data type, which we can see by calling the type function again. It's a float. That is, it's a number that can be expressed as a fraction, or a number with something after the decimal point that isn't 0. The other basic mathematical functions are here too. We can add, we can subtract, and we can exponentiate. Notice there are 2 asterisks there. The other basic data type we'll need to introduce is the Boolean type. The Boolean type is either true or false. You're most likely to create a Boolean type by asking whether 2 things are the same or not, or asking whether one number is greater than another. Be careful with the double and single equal sign. You use the single equal sign to assign a variable, but a double equal sign to test equality. A list is an ordered collection of data of any type, perhaps a mixed type. You can access elements using a square bracket. Let's make a list of the integers 0 to 10. Here's a quick way of getting all the even numbers using the modulo operation that we saw before. At the end there, if x mod 2 equals 0, again using the 2 equals. To test for equality. This shortcut of making new lists out of old lists is called list comprehension. I really like them, and you'll probably see me use them in my code quite a bit. It takes a little getting used to. Feel free to ask if I do anything that looks too extraordinary. Lists are quite similar to strings, another data type. Unlike lists, which are sequences of anything, strings are sequences of characters. A list can either be set off by single or double quotes. There are a couple of other ways too, but this is a good place to start. So let's make a string variable. You create new variables using the equal sign, as we learned before. This says that there's a new variable that is equal to Maryland's iSchool. In both lists and strings, you can use what are called splice operations to get subsequences from the string. If we just want Maryland from Maryland's iSchool, we can say we want everything before the 8th character. If we just want the space in the middle, we can just grab the 10th character. What's often convenient is that you can also use negative indices. To just grab iSchool, you can say that you want everything after the 7th character from the end. Another way to get a Boolean data type is asking whether an item is in the string or a list. This is often quite useful. Unlike other languages, you don't need to call a special function or write a for loop to check whether something is in a list or a string. For example, we can ask whether 18 is in the numbers from 0 to 10. It isn't, by the way. And we can ask whether and is in the string iSchool. It is. The most idiosyncratic Python data type is a dictionary. You may have heard about this as a hash or a map in other languages. This maps keys to values. The key can be an integer or a string, but not a list. And the value can be just about anything. This is a great way to count things. Let's create a new dictionary, map the string terp to 40,571, and then add 1 to that. Now, when you ask for the value of terp, it's 40,572. But if you ask for something that's not in the dictionary, you get an error, key error. This is an exception. This means that something went wrong in the program and Python doesn't know what to do anymore. You see exactly where it happened in your code, and when this happens to you in the future, it will. This is the kind of information that you'll want to share with me to help you debug what's going on. This means, in this case, that there isn't a low key in this dictionary. If you want to count something, you might want to use a default dictionary instead. But this isn't a basic class. You can bring it in additional classes using the import command. There's a package called collections from which you can import the class default dict. After we do that, we can now use this new class, which is a dictionary, so that whenever you have a new key that it hasn't seen before, it uses the default value for that type. In the case of an integer, this is 0. We did that by saying default dict, and the default value is an integer, int for short. So now we can add 1 to a new key without a key error. This isn't just for default dict though. We'll be using a ton of imports for statistics, deep learning, and lots of other stuff. For example, if we want the sine or the exponential function, we need to import them from the math package. Now for the weirdest thing about Python, which we'll show in the context of defining functions. Functions are pieces of code that you'll run over and over again. Let's create a function that takes a name as input and then prints hello to that name. Functions need to have an identifier. We normally name functions with lowercase names separated by underscore. After the name of the function comes arguments to the function. But that's not the weird part. Here's the weird part. The body of the function is defined by whitespace. If you don't indent the body of the function, it gives you an error. If you have inconsistent whitespaces, it gives you an error. For beginners with Python, this is the biggest problem people have. It's not as forgiving as languages like JavaScript. Once you get used to it though, it just feels right and your code looks beautiful. Inside the function, you can find new variables, do math, whatever. But the results don't leave the function until you expose it to the outside world. You can do that with the return keyword. Then you can assign that to a value when you call the function. Whatever you return from the function gets assigned to the result of running that function. Be careful, if you leave out the return, it won't warn you. It will return a special value called none. That's its own data type. Let's see that in action. We'll create a new function, but forget the return. You call it, and you get none as the answer. If you leave out an argument to a function, it causes an error. Sometimes arguments have default values though, so you can leave them out and it just uses the default argument. If you leave out these arguments, then there isn't any problem. It will just use the default instead. In the next video, we'll talk about how to combine these things together, first in classes and then in files that we grab from Git. If you want to see more videos like this, check the video description for the course that comes from the link down below. You can then see the context and the correct order for watching these videos. YouTube will gleefully show you stuff in the wrong order. If you want other people to see this video, provide a big gradient to the recommendation algorithm by clicking the like and subscribe button down below.